Okay, welcome back. We're going to continue for the formula for the surface integral. Now we're going to combine everything. Now I think still camera is adjusting the focusing. I'm not sure whether it's okay. Let me adjust it to make it a little bit bigger. Okay, we're going to combine the formula for surface integral. Okay, we're going to use a formula for surface integral. Is it good enough? Not that big enough. Let me adjust it to give better. Come on, focus it. Okay, I hope that you can see this very clearly. Okay, formula for surface integral. Okay, now we're going to combine everything together. Okay, let me write a little bit bigger. I think still is adjusting. Wonder why. Okay. F ds, okay, F ds, which is, this is what we call gauss. Okay, the gauss is coming in ready. Okay, ds, this is a big ds. Okay, later you see this is a surface. We just simplify the whole formula. This is what you will see in the books most of the time. Students always tend to confuse with this state, when they write in a single formula like this. Actually, this is very elaborative explanation that's supposed to be given for this. I've done for you ds alone. Now we already combined, but it's a dot product to that. Okay, now you can see I'm going to extend step by step. Okay, the surface actually is a double integral whereby we just use f and end is normal to the ds. That's what we learned before, right? This is what we learned before, which is a big S represented with the nds. Now we're going to combine with the f. Okay, therefore the ds can be anything that we already learned before. It can be actual, it can be a not actual, shadow, and etc. Okay, but remember f is a gauss that I introduced to you, which is gauss means it's a force. Therefore I will define this is any vector which is a force holder. Okay, force holder. Okay, can you get this logics? Okay, hopefully. Now let me start immediately with the example. Okay, remember I'm going to give you few examples only, but it's very challenging and very thorough, and it will be very extensive. Every single question, it will carry many level. Therefore you can see this single question itself will carry many level. Okay, therefore you, okay, let me go through first one. Evaluate. Okay, sometimes they use this formula, okay, on the top. Very simple, look simple. Student also, they might think is something similar to line integral. This is not a line integral at all. Okay, remember S represent surface. If there is a C, maybe it's a curve. Okay, line integral, but this is a S. And okay, I'll write the complete formula anyway, because this is since your first time you're looking at this. Okay, they put the ds, but in again some books they will use this as a big ds. I'm just wanted to tell you, but this one they will put it that as a front and okay, for the entire surface S of the region, okay, at the surface of the region, okay, by x2 z2 9, and you can see x greater than 0, y greater than 0, z greater than 0, and y equals to 8, where okay, now you see the gauss, okay, you see the gauss as well. The gauss is equals to 6ci 2x plus y j xk. Okay, remember, this is the gauss. Okay, now two things to clarify to you. This is the question, and as we know, this is the gauss. Okay, this is the gauss I introduced to you as a gauss. Okay, now I'm going to sketch. Okay, based on what am I supposed to sketch? Okay, this is very important question. Sometimes students tend to confuse. Okay, they tend to confuse and they might think, which one am I supposed to use to draw, sketch my surface? Surface is this. This is the surface, okay, that you need to draw. Okay, this is the surface that you need to use to draw. Okay, now I want you to understand this process first. This is what? See, did they mention anything about this? No, you just need to sketch by yourself. That's why I'm saying this required a lot of skills. If you don't know how to sketch, then definitely you cannot solve this problem at all. Okay, this is required a lot of sketching knowledge also. But some of the sketches will be very complex, but I'm not expecting you to go up to that level, but at least you should be able to sketch the simple things which is already told you. But I will get back to this again. Okay, the sketching model, the sketch later, I will revise this again. I will do the revision for this portion, but before that, okay, I'm going to introduce to you the logics of or the application, not to say application, how to use this formula. Okay, how to use this formula called surface integral formula. Okay, now let me sketch. This is one cylinder. Okay, when you draw the cylinder, look at, I'm changing the concept. Y. Okay, y. This is a z. This is a coordinate system referring to different model, and this is the sketch. Okay, I'll name it this: A, B, O, C, D, E, which is equals to 8. Okay, this is 8. Okay, how do I know? Few questions. Maybe I ask you back. How do I know this is first quadrant? Remember, you see, it's a very clearly say x is a greater than 0, y equals to greater than 0, z equals to greater than 0. Sometimes they put equals to 0, equals to 0, equals to 0. Some books they put it that. Okay, to show, indicate that is a first quadrant they are referring to. And y equals to 8, and this is a circle. Okay, you can see the circle, and you're pulling the circle to the y. Okay, and you can see the force also involving K. 3 combinations. Okay, the goes. Okay, now we have how many surfaces? First, I list down the surface. Okay, I want you to identify the surfaces. We're going to do every single surface. Surface AOB, I call it Okay, we will do AOB. Okay, and the surface step by step. Actually, A, B, C, D. Okay, one of the most important surface is A, B, C, D. Okay, this is an important one, but okay, this is A, B, C, D. Okay, this is my priority later, but I call it this is S1. Slightly it may run. Okay, please don't confuse, huh? But actually I make it a little bit flexible. Okay, and OBE, OBED. Okay, what happened? This is, I forgot to write. AOCE. What is that? AOCE. Okay, this one I call it as a S2. ABCD S1. Okay, this one you don't like it, leave it like that. OBED. OBED, I call it S3. Okay, later I get back to this one. Okay, this one is AOB S4. CDE, I call it as S5. Okay. These are the surfaces that we identify here. Okay, we're going to calculate now step by step the logics of surface integral. Okay, how the surface integral really works. Why are we doing this? I didn't explain these portions everything, but just give you idea. Okay, in order to calculate this surface, the big with the what you call NDS for the small scale, you need to calculate. In order to calculate this force, okay, let me explain to you what is we are trying to do. Why are we doing calculation, this calculations? That's the first question. That if you don't understand really, simply I write this formula, I wrote it this formula, then I've given one question, then I'm asking you to solve this. But first of all, you need to understand what is going on here. Okay, let's say this is a box. I am throwing this goes inside this cylinder. Okay, kind of quarter cylinder. Okay, quarter cylinder. When I throw this goes, let's say this goes can be any charges. Could be, it could be a charge holder, right? Charges, or it could be electrical charges or anything. When I charge this, okay, throw this goes inside, the charge will react, okay, on this box. Actually, we wanted to see how these charges scattered on the surfaces, one, and how this charge will react to the external world. That is our concern. We are not interested how the charge is spread on inside the volume, okay, of this cylinder. We wanted to know how these charges scattered on these surfaces. Okay, that's why we are learning the surface integral. I forgot to explain that portion into detail. I just okay, the reason that we are learning surface integral, we must remember when we throw this inside the surface, on the surface, for example, this goes on the surface here, it will be scattered some places. Okay, the total charge can be 0. When I touch, nothing will happen. But some spaces, some surfaces, this goes can play important role. Okay, in this is maybe is A, this is B. Okay, the charge when it's scattered on this, okay, could be later when I calculate for this the surface integral of that, the reactions, okay, it will be 0. Okay, that means it's a 0 impact. Okay, 0 impact. But when I touch on the B, maybe the surface of this B, and it may give me some impact to me. Therefore, it could be a 3, okay, joules or whatever. Because it can be anything that depends on the ghost that we are throwing inside, and what we are calculating is on the surface, or we are throwing inside. Okay, depends on the problem that we're going to analyze. Therefore, remember, if it is electricity, for example, electrical charges, when I touch this, okay, as external, I don't know what is this box about. Okay, it depends where am I touching. Okay, when I start touch, I need to know where the current actually is spreaded, and it may react to me. That's what we're going to analyze here. Okay, this is the idea behind this surface integral. Okay, now it could be charges, it can be anything, again, as I say. Okay, but I'm giving a good interesting analogy, which is charges, especially electrical charges. Okay, when we calculate this, you need to remember, we need to total up everything. Okay, when the surface integral, it means we are integrating all the values, the charges, the charges that has been generated by this course on these surfaces. Therefore, it will be, you need to calculate S1 plus S2 plus S3 plus S4 plus S5. Wow, you got a lot of job to do here. Okay, you need to calculate every single piece of the surface. Okay, that means if you 5, if 7, 10, 100, 100. Okay, therefore it's a lot of works. It's a lot of work to do in practical sense lah. Okay, now we're going to see one by one. It's not easy. I'm going to pick certain examples step by step. One of the very difficult one is this A, B, C, D. Not is it very difficult. Okay, therefore I just start using most probably the easy one. Maybe I start with the S2. After that I'll go to S3 or something which is easier one. Rest all easy except this surface A, B, C, D. That's why I put it as a priority here. Then rest I'll show you. Then later I'll concentrate on this A, B, C, D. Okay, why am I okay, it's not the first time itself when I start showing this, and definitely you will go a bit confused. Okay, therefore first let us do the easy one. Okay, the simple one that I'm going to introduce to you, we're going to calculate S2. Okay, we're going to calculate S2 A O C E. Okay, we're going to calculate this surface integral for this. Okay, the first, when I calculate the surface integral for this, let me sketch. Okay, you see this first. A O C E. Okay, we are interested on this surface. Let's say, let me sketch this surface first. Okay, this surface is a Y, is X and Z. Okay. This is the surface, and this is a 8, and what else we can say about this is a E. Okay, this first, let me put it C A O. Okay, then can you find out this? Easy, right? Okay, how do I know? Okay, go back to this one. Always remember, this is 3 squared. That means this is 3, right? 3, 3, 8. Therefore, this is 3. Okay, it's known value 3, and this one is 8. Okay, this is a 8. Yeah, this is okay. It's a 8. Okay, the value of that one is a 8. Okay, we don't concentrate inside the box because we are not interested in inside. We don't know, we don't care what is going on inside. We are interested outside, how the surface can react to the outside. Therefore, always remember, in any surface integral, we never consider inside. Okay, I repeat this word. Always for the surface integral, we are interested on the surface react to the environment. Okay, therefore can I put it that as a combination of surfaces, combination of surfaces, that's a very important one. First, second, surfaces exposed to external world. It's not an internal world. What I mean by external world, what I mean by that, surfaces exposed to external world, what I mean by the external world, external surfaces outside, outside to that box. In this case it's outside of this box. Is it clear? Combination of the surfaces is we are trying to identify all the combination is very important here. Just to say all the combination of the surfaces exposed to external world. Refer. We are referring to surfaces exposed to the external world. I hope that these two notes will help you. Referring, I just say referring. I hope that you can write down here. Refer to surfaces exposed to external world. Get back here. What is the external? The external is facing inside or outside? Which one is exposed to? This one is exposed to outside. Remember, what is this? This one is outside, right? Outside. That means what is the end? The end for this case is, the end is negative k. How do I know? Again, z. Can you see this? Z is opposite to the z. Opposite to the z. Therefore, we call it this as a n equals to negative k. Is it a smooth surface? Yes. Please make sure this is a smooth surface. For sure, this is a smooth surface. But A, C, D, B smooth surface? No. Later I'll show you why. It's very obvious. You touch anywhere, it's a kind of this, this paper. If I touch, if it is a smooth surface, wherever I touch, it's a very straight line. That's what I wanted you all to understand the logics of this. What is z at this point is 0. Therefore, this is another information, valuable information that we can capture. What is the, can we do the combination of this f combined with the n? Yes. I'm teaching the standard procedure. Please follow this. First, try to gain as much as information you can collect first. After you collect that, you try to work on the f dot n product. Goes times with the directions. When you do this, this is a 6zi plus 2x plus yj xk dot product with the negative k. What you will get? In this case, you will get x. Can you see that? Negative x, negative. Therefore, kk. Dot product, remember, it's not a cross product, it's a dot product. Same. The same will produce 1. Kk, 1. Therefore, negative, x. Rest of the things disappear. Therefore, we get x. Clear? Okay, I hope that you can follow. Okay, now we see ds. Okay, we are going step by step. ds. Is ds is actual surface? Are we using a shadow? No, at this moment we are using actual, right? We are not using any shadow. Straight away we are using this. Later I'll introduce to you the shadow. Okay, this will be a dA. Therefore ds is actual. Therefore we are referring to the actual and very important, ds is smooth. Is smooth. Can you write? Can you see that? Actual and ds is a smooth. Okay, now with this information, can I calculate the S2? Okay, can I just S2 F dot and ds. ds is what? Small ds, small, not a big ds. ds is a dA is what? dA is a, can you see that? dy, here, dy dx. Can you see this? dy dx. Okay, therefore dA is equal to dy or dx dy. Therefore, can I write this again? Okay, this combination, okay, f dot with the n dx dy. Okay, now this one we know is a x. Can I calculate? Very easy. It's a 8030 x dx dx dy equivalent to 36. Okay, the first question to ask here, I just quickly conclude this. 2 minute to x. No, the two times I wrote it. Okay, how am I getting this 8 3? Okay, refer to dy first. dy is a 0 to 8. Can you see that here? 0 to 8, and it's a square, right? It's a rectangle, and from here to here is a 0 3. Okay, next thing, 3 to 0, 8 to 0, dx dy x. You solve this, you get 36. I'm not going to solve this, okay, because it's a very lengthy if I start showing every steps. Okay, certain things I will just help you to elaborate, but please work on this. Okay, you should able to show that as a these things. One of the very important things, where am I get this 3? Okay, the 3 came from the logics again. I repeat, x2 plus y2 z2 equals to 9. Okay, it's just 3 2. I want you to know this part. Okay, actually it's a low and here. Okay, this is a 3. Okay, then you can see from here, this is a 8 to the 0. This is 0 to 3, 0 to 3. Okay, I hope that the first problem we managed to solve. Okay, S2 36. Okay, now let us do the next one. Okay, a little bit don't I know some students don't like immediately, oh sir, this difficult, look difficult. Don't worry. Okay, we go for S3 now. We do more, then you will find it more easier. Okay, again I repeat. Okay, we just see here, we're going to do similar model OBED. Okay, OBED. Okay, OBED. Okay lah, whatever. Okay, at least as you know, as long as you can identify the surface is important. Okay, as long as you know, okay, this is the surface, no problem, shouldn't be a problem. Okay, this is the surface. Okay, can you find out the n? The first question. Okay, first we sketch the y, z, x, Okay, straight line, straight line, very important. Okay, what is the, again I repeat again, O B E D. Okay, what is the size of OBED? Okay, you see 3 here, 3, this is 8. Okay, clear. Okay, where is the things pointing at? Outside. Okay, this is the end we are talking about here. Okay, therefore the end here is equivalent to what? Look at this. Negative I. Can you see that? Okay, what is x here? Can you see this on this surface? Is x is a 0. X is a 0. Okay, can I combine now f and? Can I run again? You need to write this whole thing again. Repeat. I'm not going to repeat after this, huh? Okay, I 2x plus y j negative xk. Okay, close whole thing, dot product with the what? Negative I. If it is a negative I, when you get combined, just concentrate on the I alone. Don't see anything else. I alone. Okay? When you times, you get a negative 6z. Okay? And what about dz? ds is a dA, whereby we can write that as a dz dy. Very easy, right? dz dy. Okay, done. Okay, can I combine? Can I combine that to find out this? F to end ds. Okay, again similar. ds is a dsy is a negative 6z dz dy. Okay, what about dy? Is a dy is a 8 to 0. Z is a 3 to 0. Okay, can we calculate this? Can. Negative 216. Negative 216. Okay, I wouldn't be I want you solve by yourself. Okay, these calculations. Okay, it's very practical. By now you should able to do by yourself, huh? Okay, but don't worry, I will, for certain cases I will explain in detail. This is easy, that's why I'm just I'm skipping. Okay, the next stage we go for S4. Okay, AOB S4. Okay, what is AOB? Okay, AOB. Okay, we're going to concentrate on this portion. Okay, now one important things. So far I can understand this is a X, this is a Z. Okay, the arrow pointing downwards. Can you see that? The arrow pointing downwards. Therefore, the first information that you need to collect here, what is n? N is negative j. Again, you see y is opposite. Okay, the opposite of y. It means it's a negative. Okay, negative j. What about y? Y at this point is 0. Y again, you look at this. Okay, here y is a 0, right? Very obvious, this information. Okay, the combination of f dot with the end, you get a negative 2x to y. By now you should be able to see y, yeah? Okay, because it's a negative j, okay, times with the 2x plus y, then you get this. Okay, combine together, you get a negative x. Okay, I don't touch this at this moment. Okay, then y, we know y is a 0, can go, now is a 2x alone. Okay, stopped here. Okay, now what about ds? Okay, ds, how do we address this ds? Now we go for the polar coordinate. See, we are playing around with whatever we learned before. dA, okay, dA. Okay, we're going to use what is dA, the surface of this. What I taught you earlier? What I taught you earlier is will go inside, you know. Okay, dr. Okay, surface r d theta. Okay, therefore r d theta dr. Can you see that? Are you agree with this? Yes. Now since we are using theta and r, we cannot use this Cartesian coordinate. It's automatically we need to change it this to -2 r cos theta. We need to change it to the r theta. Okay. Therefore, now can I combine together? Okay, as for f and ds equivalents to, okay, first I'm not going to touch this yet. Okay, combine here negative. Let me write this first. At least I want you to have a full grasp of what is going on. Okay, and done r d theta dr. Okay, and what is x? Bringing this inside. Okay, -2 r cos theta r, oh, can you see that? Sorry, r d theta dr. I'm moving very slow, you know. I know some of you might feel so bored. Please excuse me for those find it is where I'm very slow. Okay, I worried because you all copying my work. Okay, therefore when you can go for step by step copying my work, I'm allowing some allowance time, you know, for you to copy my work also. Okay, the next thing here, what is dr? Okay, what is dr? Dr, what is the r here? Can you see this? R3, right? dr. But we are moving inside. R is changing. R is changing means the changes that it can go is 3 to 0. What about theta? Theta is here 1 quadrant, right? 90. That means it's a pi over 2 to the 0. Therefore, when you calculate this, okay, okay, this is again, I'm trying to tell you, you can swap according to your these things, but I'm just showing this. The next is a theta. Very fast you can identify that. You cannot say, for example, -2 you can bring it out. Okay, you can bring it out, but let's say you keep it this as r2. Okay, the cos here, okay, cos theta d theta dr. Okay, this one just simple. Okay, sorry, where is this? Pi. This one cos theta, you integrate, you get a sine. Can I start straight away moving? Okay, I just change it, sine. Okay, sine integral, which is a pi over 2 to 0. Can you do this? Okay, it's very easy. Okay, when you calculate, you will get -18. Okay, make sure you should able to calculate that. Okay, I know I'm very slow. Because I wanted to make sure that you follow the work carefully. Okay, done. Okay, now we go final one. Okay, CDE. on the top of that, we call it this as S5, right? S5, yes, it's S5. Okay, let me sketch. The S5 is on the top of that. Okay, on the surface C, D, E. Okay, this one. Okay, now we start with this. Okay, could you find out? You see, this is we are looking at the surface here. Okay, the surface is similar to the arrow to the y. That means it's a Cartesian is the normal is a same as y, right? Therefore the end in this case is a j and y equals to 8. Okay, f dot end product to this is 6zi 2xyj. That's why when I repeat the